Design patterns are standard solutions to common software design problems. They provide a template for how to solve issues related to object creation, structure, and behavior in a reusable and maintainable way. For software engineers, understanding design patterns is crucial because they help create scalable, efficient, and robust systems. In interviews for software development roles, particularly those focused on architecture or senior development, candidates are often asked questions about design patterns. Interviewers aim to assess not only your theoretical knowledge but also your ability to apply these patterns to real-world problems. Demonstrating a solid grasp of design patterns can showcase your problem-solving skills, coding standards, and software architecture understanding. In this video, we'll explore common design pattern interview questions, provide sample answers, and share tips to help you prepare effectively and impress interviewers. Question 1. What are design patterns and why are they important? Answer begins here. Design patterns are proven solutions to recurring problems in software design. They provide templates that developers can reuse to solve common issues efficiently. They are important because they promote code reusability, improve maintainability, and make the system easier to understand and extend. Using design patterns ensures best practices and helps maintain consistency across the codebase. Tip: provide a clear, concise definition and highlight practical benefits. Question 2. Can you name the main types of design patterns? Answer begins here. There are three main categories of design patterns: creational, structural, and behavioral. Creational patterns, like singleton and factory, focus on object creation. Structural patterns, like adapter and decorator, deal with the composition of classes and objects. Behavioral patterns, like observer and strategy, define how objects interact and communicate. Tip: show that you understand both categories and examples. Question 3. Explain the singleton pattern and its use case. Answer begins here. The singleton pattern ensures that a class has only one instance and provides a global point of access to it. It's commonly used for managing shared resources like configuration settings, logging, or database connections. For example, in an application, a single instance of a logger ensures consistent logging across all modules. Tip: include a simple example to demonstrate your understanding. Question 4. What is the factory pattern? Answer begins here. The factory pattern provides an interface for creating objects without specifying their concrete classes. It allows for loose coupling and flexibility in object creation. For example, a shape factory can produce objects like circle, square, or triangle based on input, without the client code needing to know the specific class implementations. Tip: emphasize decoupling and flexibility in design. Question 5. Can you explain the observer pattern? Answer begins here. The observer pattern defines a one-to-many dependency between objects so that when one object changes state, all its dependents are notified automatically. It's widely used in event-driven systems. For example, in a stock trading application, multiple clients observing stock prices will receive updates whenever there is a change. Tip: highlight real-world applications to make it relatable. Question 6. What is the difference between adapter and decorator patterns? Answer begins here. The adapter pattern allows incompatible interfaces to work together by converting one interface into another, whereas the decorator pattern adds behavior to an object dynamically without modifying its structure. Adapter is about compatibility, and decorator is about extending functionality. For instance, adapter can make a legacy payment system compatible with a new API, while decorator can add logging to an existing service without changing its core code. Tip: clearly distinguish purpose and usage of each pattern. Question 7. Explain the strategy pattern with an example. Answer begins here. The strategy pattern defines a family of algorithms, encapsulates each one, and makes them interchangeable. It allows clients to choose an algorithm at runtime. For example, in a payment system, different payment strategies like credit card, PayPal, or cryptocurrency can be implemented using the strategy pattern, enabling the system to switch payment methods easily. Tip: emphasize flexibility and runtime behavior modification. Question 8. How does the builder pattern differ from the factory pattern? Answer begins here. While both patterns deal with object creation, the builder pattern focuses on creating complex objects step by step, allowing different representations of the object, whereas the factory pattern focuses on creating objects of a specific type without exposing the creation logic. For example, a builder can construct a complex meal with multiple courses, while a factory produces a specific type of meal. Tip: highlight the key difference in object construction complexity. Question 9. What is the prototype pattern and when would you use it? Answer begins here. The prototype pattern is used to create new objects by copying existing ones, which is useful when object creation is resource intensive. Instead of creating an object from scratch, you clone a prototype. For instance, in a graphic application, creating multiple copies of a complex object like a chart can be done efficiently using the prototype pattern. Tip: stress efficiency in scenarios with repeated object creation. Question 10. Can you describe the MVC, Model View Controller, pattern? Answer begins here. MVC is an architectural pattern that separates an application into three components: model, view, and controller. The model manages data and business logic, the view handles the presentation layer, and the controller manages user input. This separation improves maintainability, scalability, and testability. It is widely used in web applications. Tip: mention practical advantages like maintainability and modularity. Question 11. What is the difference between structural and behavioral patterns? Answer begins here. Structural patterns focus on how classes and objects are composed to form larger structures, like adapter, decorator, and composite. Behavioral patterns focus on how objects interact and communicate, such as observer, strategy, and command. Understanding both types helps in designing flexible and maintainable systems. Tip: use clear distinctions and provide examples. Question 12. Explain the command pattern. Answer begins here. The command pattern encapsulates a request as an object, allowing parameterization of clients, queuing, logging, and undo operations. For example, in a text editor, each action like copy, paste, or delete can be represented as a command object, enabling undo and redo functionality. Tip: emphasize practical application and flexibility in handling requests. Question 13. How would you choose a design pattern for a problem? Answer begins here. I first analyze the problem to understand the context, requirements, and constraints. Then I identify patterns that address similar issues and evaluate their advantages and trade-offs. For example, if I need to create multiple variations of a complex object, I may use the builder pattern. If I need runtime behavior change, I may use the strategy pattern. Choosing the right pattern ensures efficiency, maintainability, and scalability. Tip: highlight analytical thinking and decision-making. Question 14. Can you give an example of using the composite pattern? Answer begins here. The composite pattern allows you to treat individual objects and compositions of objects uniformly. For example, in a file system, files and directories can be treated similarly. A directory may contain files and other directories, and operations like display or size calculation can be applied consistently across both individual and composite elements. Tip: show understanding of hierarchical relationships and uniformity. Question 15. Why are design patterns important for software developers? Answer begins here. Design patterns provide developers with tried and tested solutions to common problems, improving code quality, maintainability, and reusability. They help communicate design ideas clearly among team members and enable developers to follow best practices, ensuring scalable and robust software systems. Familiarity with design patterns also demonstrates a deeper understanding of software architecture, which is highly valued in technical interviews. Tip: emphasize both technical and communication benefits of using patterns. Closing thoughts. Design patterns are an essential part of software engineering, offering structured solutions to recurring problems. In interviews, understanding patterns theoretically is not enough. Being able to explain their application, advantages, and real-world examples is crucial. When answering design pattern questions, provide clear definitions, practical examples, and mention the problem-solving benefits of each pattern. Using the STAR method or providing code-related scenarios can strengthen your answers. By preparing thoroughly and demonstrating both knowledge and practical application, you can impress interviewers and show that you are ready to design scalable, maintainable, and efficient software systems.